Hello, welcome to today's Curiosity Conference session. My name is Gordon, and today with me I have John Sokol, and our topic of the day will surround technology and its relation to education. So first, John, would you like to tell us a little more about what you do and who you are?
I'm sort of a self-taught computer expert. I've been running around in Silicon Valley for the last 30 years, involved in countless startups. My focus lately has been on pure robotics and robotic education and things related to that.
Nice. So right now you're working at Robotera, and what's one project there that you're proud of or you're excited to have worked on or
Uh,
working on?
yeah, there's a couple projects we worked on over the last year and a half, 2 years. One was a telescope, and another one is a snake that uses reinforcement learning to move, and also we got involved with a cat and a few other robots like this. So I hope to finish that up as well.
Nice. So you think that these robots seem to be able to teach kids or to educate people in a way that that is unique and can teach them about like the fundamentals of artificial intelligence and all these programming skills. So yeah. So yeah, what do you think about that?
Yeah, there's several simple, I guess you'd call them AI examples out there that I've managed to put together that can teach AI principles in basically like 2 pages of C code that a student can understand. Simple things like learning the rules and how not to fall off a table on a little driving robot, for example.
Right.
All the way up to a reinforcement learning where we've got a 8 servo articulated snake. Maybe we can drop the video of that in here. That will learn how to move on its own and figure out what the best movement patterns are currently using rules from Mathematica.
Wow. So are these implementations something of like a simplified version for towards a young adult or like teenager population, or is it the same sort of coding or structure that will be used in an actual like AI implementation, not like on a professional level?
Well, maybe, again, AI is an enormously large field. So the goal here was to have a robot that you could build over the course of, let's say, a class or two, and then in the course of a 1-hour period, apply the learning algorithm and watch it go from flailing around on the table to being able to effectively move itself. And be able to make it so that we can apply that to almost any kind of robot that we drop over there and have it figure out how to best move itself in a situation without us programming it.
That is cool. And yeah, I guess that kind of relates to, I think it's really interesting how you can combine AI in such a way that makes it, I guess, visually intuitive for the students to understand what is the inner intricacies.
Mm-hmm.
And how do you think that sort of intuition plays out over like having this intuition? Would that help them in the future, or like in what aspects would that help them in further learning of STEM and or future knowledge?
Well, again, the goal was to be able to teach a couple of aspects of AI and machine learning from the perspective that a lot of the AI and machine learning is really an extension of data science, which is statistics and data analysis. And then be able to apply this to robots, again, in the case of the reinforcement learning or other learning algorithms, that we can teach them this in the course of an hour, watch it, and get some intuition for what it's doing, and basically demystify what's going on under the covers. Something that's small enough and simple enough.
Right.
So.
Yeah. So seems that, so as I remember, like if there's one part of using AI in the product itself. What about as Robotera, or are you in the field? Are there any ways of using AI to help learners learn better? As in like using AI in the teaching program or solutions itself?
Well, Robotera is not doing this directly, but with a lot of online education, I think that machine learning and AI can be used to optimize the curriculum, basically learning what type of courseware is most effective for different types of students, and be able to identify, what students, let's say, are a more audible learner or a visual learner or hands-on, different learning types, for example, or ways of connecting them with the content better.
Right. Would you think one implication with that sort of like identifying strengths and weaknesses, would there be a potential that AI would create like a self-reinforcing or like a self-fulfilling prophecy where it's sort of like a slight bias in the initial conditions would lead to more and more polarization? For example, if the AI itself identifies a student as like a visual learner, would it be a possibility that even though the student might not actually be a visual learner, but because of like how the algorithm might propose or like guide the student in a way to become better at visual learning, to create like sort of a bias or like a deviation in their strengths and weaknesses where they become a very good visual learner but falls weak on other categories as
Well,
it's
I think we're a long ways off from having this kind of almost like
implication
a
question.
confirmation bias or some sort of self-reinforcing thing where it sends students down certain paths. Certainly we're afraid of that happening with our police and other institutions, where suddenly it's like, oh, you've had problems in the past, so we're just perpetually red flagged. Our credit system seems to do this to people. It's like, oh, you've got bad credit, so we're going to like give you harsher scores for every little minor infraction.
Right.
Where somebody with good credit, you're late on a payment, it just kind of like, oh, it's nothing.
Mm.
So
Okay.
yeah, these systems are currently, been used in banking and credit for years. These kind of machine learning algorithms, bots, constantly looking at odds and sizing people up, if you will, for insurance rates, for example.
Right.
So
Yeah. And not a problem in like the educational field
it's
for
not
now.
a problem yet, but we call them like filter bubbles in Google, or Netflix
Right.
recommendation engine was a famous one, trying to figure out
Right.
what movies you're going to like. So
Yeah.
I kind of see it as, there's 20 different ways we can teach you trigonometry, which set of videos or instructional material is probably going to be most effective for the student. I don't think there's going to be a lot of room to like really deviate too far out of the lines, though, in that.
Right. Especially with like a more fundamental knowledge, it's hard to actually do so. But yeah, speaking of the ways that you can teach students, I'd assume like a part of these sort of algorithms might also be focused on providing feedbacks for problem solutions. And in the case that perhaps if there's like 10 ways to solve a problem, which I guess more of a common like phenomenon like programming, how would a algorithm go about like providing feedback for like the varieties of combinations of way that a student could approach a programming problem? I
Well, I
guess
mean,
there's
the
absolutely
algorithm's
the optimization. Yeah.
not very good at finding what's wrong so much as making predictions or guesses. For example, the prime example is, let's say, reading handwriting on a letter, right? Is that a 3 or 5, or sloppy handwriting,
Mm-hmm.
kind of stuff. And so in the case of applying this to a student or is learning or something like this, right?
Right.
Certainly regular programming algorithms, just if then, did they get the right answer, for 1 + 1?
Right.
It's pretty straightforward, but figuring out, if the student's having trouble, how to address it, or just gauging what the best approach is. So my feeling, though, is it's more of think of it this way. With AI, you start building bots. Now, these bots aren't necessarily physical things. These are software entities,
Right.
but they assist you. So you're trying to achieve a certain goal. and suddenly you're able to create a software entity that will look for certain stock behaviors, or alert you for certain things, kind of like Amazon Echo. Now it's like Amazon, let me know whatever, and it'll give you some information. So these are various uses for AI, but actually getting to the point where the student has some understanding of what these tools can and can't do, and how to apply them. And I see them as more of amplifying a teacher's ability to, let's say, currently one teacher split up against 30 students, but with AI, it's like having, a room full of really dumb teacher's assistants helping. So there could be effectively some interactive one-on-one with the student going on in a way that the teacher wouldn't have time to like correct them and go, well, no, this is what you did wrong.
Yeah. So it's kind of facilitating like the more low level sort of learning process, while the teacher may help with like the more higher level, or I guess more complex sort of, or like hard to define issues within the learning.
I would imagine the teacher ends up doing more of a supervisor role rather than a hands-on role at some level.
Yeah.
Like the first pass is like, go watch the video, use the online tutorial or some, interactive aid for that particular coursework. And then the teacher's monitoring the process,
Right. Yeah. Because I mean, knowledge deliverance doesn't really need a teacher to be present. I mean, or, like they could just read textbooks.
So there was a scene in one of these Star Treks with all the Vulcan students in their little computer pods, learning kind of thing, I kind of see that every student's going to be sitting in front of a laptop, and most of the coursework's going to be there.
Yeah.
Or some screen.
Yeah, in that case, would it be a course for like social emotional learning? Or, I mean, I guess you just have like recess time and whatnot. But yeah, sort of that devoid of, I mean, not devoid, or the relatively lesser human interaction within classroom may have other effects.
Well, I think our understanding of what classrooms are is going to change pretty drastically too, because the computer industry has really changed the way that people have managed to work together and learn and share information and knowledge in a much more efficient fashion. And I see that culture now propagating out to other fields and industries. The biotech people are starting to pick up on it and take advantage of GitHub and other tools, and many other fields as well, disciplines. So in the end, basically, people in the future are going to be learning for the rest of their lives. It's not like you go to school, you get your K through 12 and you're done, and maybe you get some college with some module beyond that. The reality is things are perpetually moving, and every time you sit down for a new project, there's a lot of learning that's going to have to happen, and continuously, because things are constantly evolving and changing. And getting the students in the mode where they can sit down and you can point them in any direction and they can start learning on their own and go, oh, okay, here's how gravity and acceleration work to do a cannonball game or something to this effect, right? And how can we provide them tools and AI assistance where suddenly they can have the equivalent of like a hands-on mentor that will happily explain to them all the physics and gravity and things, rather than them having to fish through 100 hours of YouTube videos and 1,000 pages of physics texts.
Right. Sort of where AI has a role of like, because I mean, I know like we have like analogies like everything is on Google now, and like I mean that's not an analogy, but like with everything being on Google, like AI is sort of like our sort of like an extension of our brain that helps us like sift through information faster than we could process.
Yeah, but Google doesn't digest information before giving it to you.
Yeah, just
I think
everything.
of it this way. Imagine you can hire a personal assistant. You go, okay, we want to figure out how to draw a circle. What's the math function for that? And instead of having to go through and fish through all these pages of websites and theory,
Mm-hmm.
somebody who understands this stuff can come back to you and go, okay, yeah, there's 3 different algorithms for doing this. And depending upon what you're trying to achieve, you're going to use one of these, right? Pythagorean theorem, for example, versus sine versus cosine.
Yeah.
And why would you choose that? And something that can sit down and explain this to the student so that they can be more functional hands-on. But at the same time, there's not a lot of point in rote memorization, because in the future, those AI are going to be there for you, actively helping you. So really, it's becoming more of learning how to take advantage of these tools to empower you. With today's tools, you can do stuff that a guy with a PhD couldn't do 30 years ago, and now a 12-year-old kid can pick it up and slap together some face recognition on a Raspberry Pi. The code's there. You just you learn how to download the examples, and boom, you're rolling. So all of the knowledge to learn is there. Now the question is some kids figure out how to pick up those tools on their own and learn how to read the docs and the manuals and get up to speed, and a lot of kids don't. So getting them to the point where they have that self-motivation, self-learning ability, I think is going to be a key to surviving in the future, because the AI really should be a tool to speed up your ability to learn.
Right. Wow. Yeah, I mean that seems like, especially with us in the States, like the educational system would be very hard to prepare us for that kind of forecast, I guess.
Well, there was some example where they're basically training, factory workers for 70 years ago, still.
Right.
And not information workers where it's like, oh, okay, we're going to have to write or develop something to do X. And here's a whole bunch of things you don't know about, and you're going to have to read up and learn about, X, Y, and Z to accomplish your mission. And that's all like learning new subjects without a teacher sitting there holding your hand.
Yeah. I mean, with regards to that, what was your experience like going through, the States educational system a few decades ago, and how do you feel like, what kind of changes would you make, to the past system or the current system if you could do so?
Oh my God, I did not have a good experience at all in my public education system. And so I was more focused on making money and learning and doing stuff with my computer and ignoring the academics of the school system.
Wow.
So later, like having to come back up to speed on, basic English skills, for example. I look back at my writing from 30 years ago, and I really look illiterate.
Wow.
But my education was very lopsided because I was very unhappy with the academic school system at the time.
Right. Yeah. But I guess with like the self-initiative, like you could pick the English back up, like whenever you felt like there was a need of it.
Well, I have in the course of 30 years of doing business, business plans with misspelling and bad English, and at some point it's just doing it over and over and over again has forced me to clean up things.
Right.
But even just communicating on social media, where a lot of it's all typed, for example, has kind of forced me to improve my spelling and in English. So as soon as I put some flub out there, I've got several friends on me going, "Oh, you misspelled they."
Yeah.
Or there.
I guess that's a better way to learn. Instead of a teacher giving you feedback, you have friends, which I think gives more motivation for things.
Certainly peer
Yeah.
pressure provides a lot of motivation. So
Yeah.
yeah, having a group of friends. Well, I'm seeing my son right now trying to do these like programming hackathons, and
Mhm.
the thing he's finding the most difficult is they don't know how to collaborate.
Mm.
So, you know, I grew up and I was involved in the publishing of the first open source operating system, the 386 BSD, that eventually like the Linux guys came over and they had their thing. They borrowed a lot from what we had posted, but the most interesting thing that is they were more successful in organizing the group and the community and distribution and stuff, where there was a lot of chaos when we first hosted, for example.
Right.
And learning how to communicate and interact as a group and sort of on board with other remote teams and work remotely, like especially in this COVID-19 day and age, is a big deal. You know, it's a skill that very few people have the ability to do that, where they could just work at home. You know, even though there's literally nothing at a desk other than the computer at their office, for some reason, you know, they just don't have the skill to, let's say, communicate effectively over email and other means to make up for not physically sitting next to someone.
Right.
And even then, when you put people next to them, you know, just learning how to cooperate and work as a team is difficult. So if the schools taught that ability for students just to collaboratively work together, that would be an enormous benefit for you know, the next generation of information workers. You know, I don't care what they're doing, marketing or, you know, stocks or anything, right? Let alone programming and AI, where you end up with larger and larger teams collaborating.
Absolutely. Yeah. I guess that's kind of hard to teach at school. I guess especially about the remote working part. Can't just have students learning at home and trying to create an environment. But yeah, I guess that's with everything.
Well, so there's different schools I've seen. There's like the Waldorf schools, for example, where they've got a very open, creative environment, very different than the public school system, where, you know, and now I'm looking at what the kids were being pushed through, and they've got like packets, which were completely mindless, you know, and the teachers spend an enormous amount of time organizing and grading these packets of stuff back and forth, you know.
Right.
And a lot of that should be a program, you know, on the computer, doing most of that heavy lifting. You know, even like grading essays and writing and stuff like this could be done by AI easily.
Yeah. Or like the AI could get some objective scores where humans could score on like the creativity part or whatnot.
Yeah. So, you know, they had the AI that was looking for plagiarism in the higher end universities. So when you submit a paper, they put it into the engine and see if you plagiarize anything.
Would that be AI, or is it more like comparing text to text?
Well,
I guess there are probably
again, it's kind of quasi AI, because again, they're using these statistical means of going, well, you know, your essay's, you know, a 92% match to this other document or something, right? And so they're able to catch more than just, okay, we just rearranged a few things and you know, we swiped a paragraph here, you know, and change something. They'll catch that.
Right.
So it's more than just like a direct, you know, pattern match.
Right. Oh yeah, I'd imagine, because you can change synonyms and maybe that will catch it too.
Yeah.
Yeah. That's true. But yeah, I do wonder like if essays could be scored objectively. It's kind of like asking, I don't know, AI to critique art.
You know, it's extremely good. So they've got it now where they can, you know, throw a bunch of papers in the grades, and then throw a paper in, and it gives you what it thinks a human would have graded it.
Right.
You know, and the beautiful part is they've got like adversarial learning and other techniques now where they took the one AI and pitched it against the other. So it's like, oh, okay, so now let's come up with completely garbage papers that pass with an A, you know, on the grading machine, and you know, it completely fakes it because you know, the grading machine tends to score well if you've got certain, let's say, word combinations or something, right? You know, so it just like pastes this document. So there's a famous one of the AI challenges is, there's like a recognition algorithm for, let's say, a dog. And
Mm-hmm.
now they give it like some completely random picture that has nothing to do with the dog,
Right.
and there's like one white pixel in the right place and it suddenly sees a dog, the AI. And,
Yeah.
they had to use an AI to find that hole
Right.
to defeat the other AI. But the fact is that, they were able to fool the algorithm in such a fashion that was so overtly gross to like a human would look at it and go, what the, why did that AI fail? Like,
Yeah.
Yeah.
I guess that's still progress we have to work with for future. Yeah.
Well, so in robotics, we call them corner cases, where you've got it working for most things, and once in a while, things will go wrong. So, I have a little cartoon from like in the 70s or 80s. It said to errors humans or really foul things up takes a computer. And it's true. You'd send a job to the printer and all of a sudden, 500 pages of random gibberish would come spewing out automatically, and that's like
that's human's fault.
Paper, Well, if you're not there watching, right, the human would make a mistake, but the machine would just kind of keep going and going and going and going and happily destroy, an entire pack of paper before you notice something was wrong.
Right. Oh yeah. Actually, coming back to the essay example, I just thought of like the case of Amazon and how the AI was biased in shifting through resumes, because I mean, as in the same case, like it replicated human biases without being biased itself.
So this is where a lot of the AI comes in is it's black magic, kind of voodoo as opposed to science in regards to how you present the data to train it. And so it's a lot like making graphs, and you say, it's so easy to lie with graphs and statistics. And the reality is when you're training a machine, a lot of it's, you're altering and shaping the data and presenting it to the machine to learn. And if you're not careful in your methods, you don't end up with a successful outcome, or you end up with all these biases that you didn't expect at the time.
Right. Yeah. But that's the more problem of the data set than actually the algorithm itself, because it only replicates the choices of humans.
Well, but again, the data set was cultivated and groomed by a human.
Yeah.
The famous one is they were trying to separate tanks from cars, and all the tanks had pictures in cloudy days, and all the cars had pictures in bright sunny days. And the machine learning algorithm was able to separate the tanks from the car images because anything with a bright sunny day had to be a car. And then when they tried applying it to other things, suddenly they realized it didn't have any connection to recognizing the vehicle at all. It was looking at the sky.
Yeah. Yeah, I guess that's a problem with data scientists and all that.
So, unintended biases and things like this, but, we're learning how to overcome them and teach them. I'm surprised that they're teaching it in schools professionally now. Well, I mean, just machine learning it, I mean, 30 years ago, it was a really obscure thing when I started.
Right. Then how do you start with machine learning 30 years ago? What brought you in?
Oh, so I would hang out with the smartest kids I can find back in the day. And so we're always, trying to like one up each other. And so, neural networks started happening, and we had, a couple hundred lines of C code with a simple neural net that was just doing, a couple layers with multiplication and things, and producing, experimenting and playing with these things. And the stuff we're doing today with GPUs is essentially just, massive versions of that simple algorithm from 30 years ago. It's just, we didn't have more than a couple of megabytes of RAM back then, and now we've got, gigabytes with unbelievable horsepower. I'm just starting to notice my browser tabs got more power than the $500,000 SGI workstation I was experimenting with at Stanford 30 years ago. I mean, in terms of like GPU and computation and everything.
Right. or how
And
much
not only
memory it
that,
occupies.
it's probably got more compute power than the Cray YMP that we were renting time on to do the computations before we sent it to the SGI even. Like
Wow.
browser tab, you know,
Mm-hmm.
in JavaScript. It's just amazing.
That's crazy. Yeah. So how we can also just connect to cloud computing like on browser tabs as well, just with more computing power at our disposal. Yeah. That's crazy.
Yeah. So
Yeah.
anyway.
Yeah. Well, that's yeah. But so I mean, if like 40 years ago, neural networks has already started like it's in an infant state. Within these 40 years, are there any things that are like, do you see being like infants that will grow to become the next big thing, or like the lead the next sort of like technological sort of big wave of advancements in like Silicon Valley?
Well, I mean, there's a bunch of big waves that have been happening.
Right.
I mean,
Yeah.
well, you know, so right now we're just at the point where we can process live video images and actually do useful things with them that we couldn't do before. And that's opening up a whole universe of opportunities.
Processing like real-time processing of images.
Our connection's breaking up here. Hello? Yeah, your video's frozen, your audio's dropping out.
Huh.
Maybe I should try and connect in again. I don't know what's going on.
Hi, yeah. Is it working now?
All right, it just came back. I was just about to leave. Is it still working?
Yeah, I think it's my VPN. The VPN got disconnected. So now I'm back, I think.
I don't know, it's not behaving well. Let me
Yeah,
try and
the video is
reconnect in.
frozen for me. But yeah, I can hear your voice, Joe.
All right. All right, are you back?
That was my end.
All right,
Yeah.
that's better.
Right. Yeah, so we were talking about live image processing and what does that connote? Or what does that, right? Like, what does that signify in terms of?
So, for example, at this point, we can take a live video from a video camera and work out the camera's movement.
Right.
We can recognize objects in the room. So you know, the kind of trivial examples, and there's even some ones that run in browser tabs now that'll open my webcam and I'll recognize the cat versus a chair or other objects in the room. It's not great, but you know, it's okay. There's a algorithms called segmentation that will separate, like, you know, people from other things and try and label them. And these algorithms are getting faster, and they've got a really nice framework now where they can compare them, you know, how much compute power versus accuracy and quality, for example.
Wow.
And you know, so as computers get faster and faster, this is going to be just, you know, normal. This kind of ability for even a low end machine to have a awareness of the environment it's in, where before computers really were oblivious to what was going on in the room around it.
Right.
So it would have a sense of context, if you will, of the situation and what's going on.
Right.
Yeah. I think that's going to change things dramatically.
Yeah, I can imagine. Yeah, I was researching on buying like a Roomba just a few months ago. And like I was pretty amazed as how like the progress has gotten since like 5 years ago, where there seems to be some level of intelligence in its like routing or obstacle aversion. But I guess like if if these processing really gets better, then maybe the algorithms and its capability could be much better than right now. Or even a new type of cleaning sort of robots could appear rather than just the floor itself.
So you keep mentioning
that's
algorithms.
A very limited thought. Yeah.
So on the subject of algorithms and the improvement, there's something called the Commodore 64 demo scene. And so basically the Commodore 64 is a fixed computer they made 30 years ago. It's like a historical piece at this point. The amazing thing is the demos that people have been able to write now that run on them, because of the advancements in algorithms, compression, performance. So just, same hardware as 30 years ago, nothing's improved at all. But what they can do on the Commodore 64 now in terms of music and video and animation is just astonishing. That and 30 years ago, just we could never dream that we could do that with the machine.
Wow.
So that's just an algorithm improvement. And algorithm improvements tend to be the larger shift. So there's Moore's law, where the computers are just getting faster because the chemistry is better and there are more transistors and they can just throw more hardware at it.
Right.
But then if you realize, I didn't need to do all these extra multiplications because we can do it some other scheme and reduce the math. My God, the performance enhancement on that is tremendous.
Wow.
So we're seeing a lot of that with the AI as well. Is not just the hardware improvements, but algorithm improvements and understanding things. So it's not uncommon for them to throw enormous money at enormous hardware to try and get, let's say, a technology going. But once the people are in there, they go, okay, we can reduce and simplify and this works just as well with 1/10 the horsepower and before you know it, these algorithms are getting more effective with less compute power.
Wow. That I didn't know about that. I mean, 30 years ago, I can't imagine running like modern services on such. I mean, a machine that predates me.
Yeah. So yeah, I mean, if you think about it now, what we're going to have mobile in our pocket is effectively what like $500,000 worth of hardware buys you today, which is incomprehensible, right? It's like a server room.
Yeah.
So the ability of generating photorealistic images and animations with all kinds of intelligence and understanding the sensors that are attached, which we can't even imagine, but I would imagine it would at least have a full depth understanding of all the structure and depth and what's going on around you spatially.
Right. Yeah. I mean, sensor.
And it would be able to do that for almost for free.
For free, like, the cost
meaning the cameras are going to be $1 a piece. The compute power is going to be $5 worth of CPU on the phone. Right. And it'll just naturally be able to do a 3D reconstruction of like every room you've ever stepped into with it.
Right. Okay. That's practically for free. Yeah.
I mean, basically, yeah. So right now, what's pushing the limit on a phone like this today? Eventually, people are going to figure out and post open source, and it'll just like some kid will just like download it and okay, yeah, I did this as part of my kindergarten show and tell.
Oh, that'll be scary. Yeah. Yeah. I guess as the future is bright ahead. Everything.
Well, I mean, I'm watching the bar, for these things come down. So even, what we were doing at the robotics club 30 years ago, people are able to do with an Arduino and a Pi now.
Right.
things considerably more advanced, you know, and I still see people struggling over how to put two wheels on a box with a battery still, you know. The wheels, the motors, the battery, you know, haven't changed all that much in 30 years, but the compute
Right.
power. And
Yeah.
not only that, the documentation on the internet where you can find, you know, hundreds and hundreds of examples and web pages and blogs and videos, you know, that will teach you step by step on how to do this. The problem is it's an overwhelming amount, and figuring out which one do you want to give a student versus sending them down this overwhelming. Okay, there's 100 ways to go. Which one? And suddenly, you know, they'll end up being paralyzed by too much information.
Yeah. So maybe then you have to rely on a recommendation algorithm to give you the one it thinks you need.
Yeah.
Yeah. Well, I think we're up to time with our session today. And I mean, thank you, John, for being here. It was, I mean, amazing and humbling for me to learn about all these advancements in technology. Yeah. Well,
All right, welcome.
Yeah.